Okay, today the topic name is quantization. So, so from last video we saw about how the sampling, how we avoid anti-aliasing, and then how to reconstruct the filter. So everything we already seen. It's now it's a quantization. So you know what is quantization? So quantization. Uh, It's a digitation of analog signals. That means we can round off the values that will be equivalent to the analog values. So that is called as quantization. So this quantization methods stabilize the value. The quantization to an analog signal. That will be convert and perform this type of function and create serial of digital value out of the given analog signals. Okay, the signal get converted into digital. There are two steps. One is sampling, another one is quantization. So sampling, we have to take the sample of entire whole data. That means a piece of data will be taken from the entire from the entire data. So you know what is sampling rate? So sampling rate, uh, it's how much sample taken within the second within a minute. It is called a sampling rate. Okay. Then so quantization. So just to see this, the blue line, this analog signal. The you know. mhm, this blue and brown line they put it here. Both the sampling and quantization result, you know at blue indicated that analog and the brown represented and quantized. So you see, so the quantization, discrete amplitude of the quantization output we can call as a representation level or reconstruction level. So there is a blue line is there and brown line is there. The discrete amplitude of quantized output we can call as representation level or reconstruction level. The spacing between two adjacent representation level we can call as a quantum. See, so there is a space between. So there is a space between two adjacent representation level. So this place we can call as a quantum or step size. The following figure, if you take it from blue line, then it's look like a staircase waveform. So also we can call it this is a staircase waveform according to the shape. So types of quantization. There are two types of quantization. One is uniform quantization, another one is non-uniform quantization. So what is uniform quantization? What is non-uniform quantization? So when that quantization levels uniformly space, that term we can call as a uniform quantization. If the quantization levels are unequal, then we can call as that is non-uniform quantization. So the level of space that should be equal. When it is equal, it's a uniform. The level of space is unequal, then it is a non-uniform quantization. So in uniform quantization, it's split into two. One is mid-rise type, another one is mid-treat type. The following figure representing there are two things, mid-rise and mid-treat. So mid rise type and mid-read type. That is mid-rise and mid-read. Okay, the mid-rise type uniform quantization. This we can call as mid-rise, that the origin, the center part. See the left side diagram. The center part origin lies in the middle of the rising part. The origin lies in the, see, that's a middle of rising part. See, so there is a rising part is there. So the origin, there is a middle, there is a rising part. So that is we can call as mid-rise type. If the origin lies, middle of the tree, it's like a staircase, like graph. This, see. So this is right. Origin lies is the rising part. So this one is origin lies treat like a staircase. So everything is like a staircase, but the origin mainly concentrated. This is like a treat, and this one is rising part. So if it is rise, we can say that is a mid-rise type. If it is treat, this is we can say mid-treat type. So mid-rise type, the quantization levels in the types are even number, and mid-treat type, the quantization levels, these types are odd number. So both mid-treat and mid rise, this type of uniform quantizations are symmetric about the origin. It's a symmetric about the origin. Then quantization error for any system during the function, there is always different in the value of its input and output. The processing of the system and results, actually what is quantization error? You know, Actually any system having error. If you consider any practical system, there is a difference between input and output, that is called, we can say, that is a error. So difference between input value and its quantized value, that is called as quantization error. So there is a value that is called as, we can say, as input and the quantized value. So this difference between input value and quantized value, that is we can say as a quantization error. This quantizes logarithmic function that performs quantization round of the value. So a analog to digital converter, ADC, works as a quantization. So see the following, the figure will explain what is original and quantized signal. The original signal, that's indicate blue line, and quantized signal, that's a brown line, look like a staircase waveform. And then the second one is a quantization error, that is also shown in blue line. So that's a, you see what's the difference between input and output. So this is, we can say, that's a quantization error. Okay, next one is quantization noise. So this type of quantization noise, which usually occur in analog audio signal while quantizing is to be digital. Quantization noise, so that will be seen next video. Thank you.